in our planning process, our goals are that we want to engage all our students in sustained work on complex problems of explanation and modeling. Any one of your principals should be really happy that that's the goal of your units. Nobody could say, oh, no, let's have the kids memorize the periodic table, right? You want to also plan to help students revise ideas over time. This is something that is not part of American science education, the whole idea that you have some ideas or hypotheses or theories at the outset of a unit, and that you actually change those, and you document how your ideas are changing or improving, and in response to what? Evidence and new information, new logic. That's authentic scientific work. Students revise their ideas over time. Your goal is also to select only the most important ideas in science to spend time on. You have to literally push ideas off the table that are trivial, and you're not going to teach those. You're going to focus on fewer, more important science ideas. And you're going to make the trajectory of the unit coherent for students. So this is not the way teachers normally plan. So how most of America's instructional units are developed, I know I'm generalizing, but usually teachers select a topic like ecosystems or chemical equilibrium, and they leap directly into creating a whole assortment of activities. They skip over everything we've done. I got a topic, now we're taking the high dive, and we're gonna just talk about what activities are we gonna do and readings are we gonna do. And so the talk goes something like this. Among teachers, we'll introduce this idea. Then we'll do a lab and a worksheet on this other idea. Then we'll do a lecture on this other idea, we'll give a quiz, and this goes on in cycles for about 2 weeks. The problem with this is that you're missing all the steps that help you plan for rigor and engagement and the coherence of experiences for students. I usually use this little graphic here. These are silos. For those of you who have never been out in the country to see silos, it represents knowledge that is contained within a structure, and the kids never realize that when they learn something on the first day of a unit like this, that they should apply those ideas the next day, or that this idea is related to this one, or this one builds upon this one. Teachers, when you go into a classroom and kids are working on stuff and you ask them, why are you doing this today? They'll say, because my teacher told me so. From my colleagues in Europe, they say their metaphor was it's like the kids are on a train with the windows blacked out. The teacher knows where he or she is going. The teacher has the big picture of how all the science ideas are supposed to interrelate with one another. The kids have no such ideas. They don't know that at all. So the kids are passengers on that train. So the purposeful design of a unit would start with selecting a topic, as we did, but then the next step is we're trying to identify what the big ideas are in the standards and the curriculum and select an anchoring event. We do those two things at the same time, and I'll show you a graphic of how our teachers have done that. Then we develop an explanation for whatever event we settle on, and then we line up all the learning activities in some order that makes sense for kids learning. So it's a little bit different of a design. So what we usually do is we give teachers a 2x2 whiteboard, and we give them stickies, and we ask them to look in the standards, and they pick their topic like ecosystems or chemical equilibrium, and they look in the standards, and they just pick 4 of the most important ideas, 4 of the most central science ideas out of the standards, and they put them across the top of the whiteboard. Then they take 4 ideas that they think are the most important from their curriculum, and they put that across the bottom of the whiteboard. Now, so many teachers have told me in the last 3 years that they have no curriculum whatsoever, that we actually have done away with the bottom row. We've just asked them to look in NGSS, select for your topic, try to find out 4, 5, 6 ideas that are related to your topic, and write those on stickies, put them on the whiteboard, and then you have to pick 2 that have what we call the greatest explanatory power. You could tell which ideas from the standards have explanatory power because this should be the question you ask yourself. If my students could only understand these ideas that I move towards a center, then they could explain most other big ideas in my unit. This is really hard for teachers to select one or two that should be in the middle. And then those are your core ideas. I see you taking pictures of this. It will all be available to you, the whole PowerPoint. So here's an actual whiteboard that somebody had done, and this is about plate tectonics. And you can't read it, but I'll tell you what is in the middle, what they moved to the middle. So this is earthquakes, I think, and plate tectonics. So in the middle, they had the two, they thought that these two on the right were the most important. Plate tectonics can be viewed as a surface expression of mantle convection. And then they said convection during plate movement, which is not even a sentence. So we have asked our teachers now to take whatever those two ideas they put in the middle, they have to be in full sentences so that the teachers know what they mean and that I know what they mean. So when I said to my students, this is my teachers, the middle thing is not even a full sentence. You don't know what you mean by that. So then they wrote the sticky on the left, and I'll just blow that up. Here's what they wrote. Instead of convection drives the mantle, here's what they wrote. I won't read it to you. You can see it, can't you? So it took about 10 minutes for these two teachers to actually come up with that sticky, but they were doing such heavy-duty intellectual work to come up with that. And then once they had it, they thought, yes, this is at the core, no pun intended, this is at the core of our unit. If our kids could just understand that, they could understand nearly every other part of subduction, plate movement, all that other stuff. There's an alternative to doing it on a whiteboard. Physically, you can just have cards out on the table. These teachers are working with the standards, but they've also got the cards. You can see the cards out on the table. They've got way more cards than they need around the periphery, and they are trying to draw some to the center. They got 4 candidates in the center. And this is super hard work. You can see the quote. We struggled with it, but it was really valuable. I hear that all the time from teachers. Again, this is not something you can do for every unit. You don't have time to do this. But it is something you can make a summer project out of for a unit or two when you work with your colleagues. That's possible. So here is the explanation that we came up with for the tanker. And all of the colored text segments correspond to a single idea that needs to match up with an activity. I know you can't read it from back there, but you've already looked at something like this with the explanation for the singer who broke the glass. But this is a whole explanation. Down here, we realized after a couple years that some of our kids were so advanced that they would come to a possible really good explanation for the tanker within just 5 or 6 class days. So we had to challenge them. So we added this bottom part. And our anchoring events always have a beginning, middle, and an end, a before, during, and after. So here, this is the after the tanker has completely crushed. Our question to our more advanced students was, why doesn't it crush all the way down so that there is 0 volume? And your explanation has to be completely in mathematics. That challenges our best students, keeps them engaged throughout the rest of the unit. This is the way we usually put our activities in order to answer your question way back there about how do we order those activities. We usually, when we think about all the activities that line up with our explanation, we put some of those activities roughly in the first third of the unit, roughly in the middle third, and then the final third. We know which activities go in those thirds, but we don't line them up perfectly. This one exactly follows this one and this one. So we rough it out in thirds first, and then we use one of these rules to decide which ones go first, second, third, and fourth. Here's one rule you can use. Start off with more familiar ideas to students early, and then move to more abstract and unfamiliar ideas. Another option, start with ideas that are prerequisites for other ideas, more basic ideas here, and then down here are ideas requiring the integration of multiple ideas together. And then your comment back there was about this third option. There are some ideas that come in the first part of the causal story. If you're telling the story of the tanker or the guy breaking the glass with his voice, then early in the story of the guy breaking the glass with his voice is his own diaphragm or studying the vocal cords. And that would come first. Later on, Down here, the glass breaks. This is available on the web. Should I just stop? Should I just drop the mic like this?